The amount of data produced on a daily basis has steeply increased in the last decade, driven by widespread adoption of mobile devices, conversion of media and other content to digital form, the rise in number of embedded devices, and many other trends. Organizations are collecting, storing, and processing this data and use it in many ways, including producing business insights and identifying trends for better decision-making of managers and other stakeholders, generating automated recommendations by using machine learning, improving products. Data scientists and others employ a wide range of approaches for analysis of their data. An important set of methods involves clustering or segmentation of data in groups of data points so that data points in the same group are very similar and at the same time distinct from data points in other groups. Clustering belongs to the unsupervised machine learning algorithms, which means that there is no target variable to help in the learning process or in finding structures in the data. One practical application of clustering is customer segmentation, where customers are divided into groups that reflect similarities among the customers within each cluster. By dividing customers into segments, businesses can optimize each customer's importance to the business. This approach allows companies to modify products according to clearly defined customer needs and behaviors, helping to better cater to the diverse needs of different types of customers. Now it comes time to more closely introduce the customer segmentation application and start action. For practical implementation, we will utilize Google Colab notebooks. At the first stage, we need to import all necessary libraries that will be beneficial for our task. Next, we will import data from a file and begin a step-by-step walkthrough of all the necessary stages. Let's look at data cleansing by examining the information contained in the data to see what needs to be cleaned up. From the function used above, it can be noted that there are missing values in the revenue column. Additionally, the customer column, which indicates the date when the customer appeared in the database, is not analyzed as date and time. There are also some categorical features in our data frame, with some columns having data type object, which we need to encode into numeric forms later. First, for the missing values, I will delete the rows that have missing income values. Next, I'll create a function from the customer column that specifies the number of days a client has been registered in the firm's database. To simplify the task, I will take this value relative to the last client in the record. Thus, to get the values, I have to check the newest and oldest recorded dates and create a new function to calculate the number of days customers have been shopping at the store, relative to the last recorded date. Next, we will look at the unique values in categorical features to get a clear view of the data. Following this, let's perform the following steps to develop some new features. Extract the age of the customer from the birth year column, indicating the birth year of the respective person. Create another column spent to indicate the total amount spent by the customer in different categories over a period of 2 years. Create a children column to indicate the total number of children in the family. To understand the number of family members, create a family size column. Simplify the education column by creating 3 categories for easier calculation. And finally, delete the unnecessary columns. By following these steps, we can ensure that the data is clean and ready for analysis. In this task, there are many factors based on which the final steps will be made. These factors are mostly attributes or features, but the greater the number of columns, the more difficult they are to handle. Many of these columns are interrelated and hence redundant. Therefore, we will perform dimensionality reduction on selected objects before passing them through the model. Dimensionality reduction is the process of reducing the number of random variables under consideration by obtaining a set of principal variables. This method reducing the dimensionality of such data sets, increasing interpretability, but at the same time minimizing loss of information. For this project, we will reduce the dimensionality to 3 principal components. Now that we have reduced the attributes to 3 dimensions, we will perform clustering, specifically agglomerative clustering. Agglomerative clustering is a hierarchical clustering method that involves combining examples until the desired number of clusters is reached. The steps involved in clustering are use the elbow method to determine the optimal number of clusters, perform clustering using agglomerative clustering, and lastly study the clusters formed using a dot plot. From the elbow method graph, we can conclude that study the clusters formed using a dot plot. From the elbow method graph, we can conclude that 5 is the optimal number of clusters for this data. Next, we will fit the agglomerative clustering model to obtain the final number of clusters. Since this is unsupervised clustering, we do not have a labeled function to estimate our model. The purpose of this part of the paper is to examine the patterns in the clusters formed and to determine the nature of the clustering patterns. To do this, let us examine the data in light of the clusters using exploratory data analysis and draw conclusions. First, let us look at the group distribution of clustering. The clusters, as we can see, are fairly evenly distributed. From the above graph, we can clearly see that cluster 1 is our highest volume of customers, followed by cluster 0. We can examine what each cluster spends on for targeted marketing strategies. Now, let's take a look at how our companies have fared in the past. So far, there has been no overwhelming response to these campaigns, very few participants overall. Moreover, no one is participating in all 5 of them. Perhaps more targeted and well-planned campaigns are needed to increase sales. Unlike the campaigns, the proposed deals have been successful. They have the best result with Cluster 0 and Cluster 3. However, our successful customers from Cluster 1 are not very interested in deals. It seems that, overwhelmingly, nothing appeals. Now that we have formed the clusters and studied their buying habits, we can look at the customers who are in these clusters. To do this, let's profile the clusters formed and come to a conclusion about who is our top customer and who needs more attention from the retail store marketing team. To solve this, I will depict the characteristics that indicate the personal qualities of the customer in view of the cluster they are in. Based on the results, conclusions can be drawn. In conclusion, by profiling the clusters, we can identify our top customers and those who need more focused marketing efforts. This allows us to tailor our strategies to meet the specific needs of each cluster, enhancing customer satisfaction and boosting sales. Thank you for watching, and we hope this analysis provides valuable insights for your marketing strategies.